Hi, my name is Professor Don Patterson, and thank you for tuning into this lecture on files, character encoding, and XML. This is the second in a series of what I expect to be about 5 lectures on XML. And in this lecture, I just want to ground our discussion of XML with some specifics about the way files work on operating systems. Some of this information may be new to you when we talk about character encoding, and some of it may be old hat, particularly some of the information about file systems. But I find that sometimes people are confused about how files are stored, and it's important to understand that, have a correct mental model for how that's working before you begin trying to do anything more sophisticated like coding or network operations. So key points from this lecture to take away. An important part of working with computer text is understanding where and how it is stored. Text is stored in files, either directly or through databases. Databases keep all their data in files also, but you usually access it through a database interface rather than the file interface. All of our text files are made of bits. Bits are a name for a 1 or a 0, and those are translated into characters using what we call a character encoding. We're going to talk about all the different levels of our XML layers here. So these all represent different ways to talk about XML that get more and more sophisticated as we build up. And what I want to do is start in this lecture talking about files and a little bit about the characters as well. So files. A file is a collection of ones and zeros that are stored on a physical device. And by physical device, I mean something like a hard drive in your laptop or your desktop. A flash drive, like a thumb USB drive that you insert into your computer and store a file on it. Or maybe you send your file to some remote server in a data center, but that server on the data center has a hard drive somewhere as well where it's storing your file. There is a place somewhere specific where your physical copy of your file is being stored. It might look like this. This is an example of a file. This is an example of a Word document, actually. But instead of showing you it through the Word program, I'm showing you the raw zeros and ones that are inside it. And you can see that it's just a bunch of zeros and ones. And in order to do anything with it, we need to be able to translate those zeros and ones into something that we understand. But this is an example of what's physically being stored somewhere on a magnetic disk, on a flash drive chip somewhere. It's hard to know. Okay, in addition to the zeros and ones, files also have metadata that come with them. This is not in the zeros and ones themselves, but this is stored by the operating system next to those files. And it has extra information that describes the content of the files. For example, the file name is metadata. The file name's not inside the file, it's associated with it by the operating system. Sometimes the size of the file, or the date the file was created, or the user who owns the file. These are all pieces of information that are about the data. When you have a file, it often has a file extension. You may be familiar with common extensions like .jpeg or other graphics files like .ping or .gif, or .exe for an executable file in a Windows environment, or maybe .html for the file name that stores an HTML document. These are part of the file name, but they don't do anything to format the file. It's just a hint to the operating system about how to understand the zeros and ones that are inside it. So for example, if you had a JPEG file and you changed the file name and you put exe on the end of it, that wouldn't make it an executable file. It would just change the file name. And if then you changed it to JPEG and changed it back, none of the contents of the file would change. You would have just changed the metadata. But the operating system expects certain programs to be able to open certain kinds of files. So if you take an HTML file and you double click on it, the operating system says, oh, that ends in HTML. I'm going to try and open your file with a browser. If you change that HTML file and make it end in JPEG, and then you double click on it, the operating system is going to say, oh, you want a photo viewer. So I'm going to try and open that file with a photo viewer. But since the contents weren't necessarily a photo because you just changed it from HTML, the photo viewer is not going to be able to make that into a photo. So the file name and the extension, They're just metadata that are hints to the operating system about what's inside. It doesn't actually change what's inside at all. The operating system typically lets you see all of this metadata in something like a file explorer or a finder window. And from there, you're able to either see it directly, or you can right-click on the file to get properties or file information and see all of the data that's available. So in Windows, when you right-click on a file, you can ask for the properties, and you can see all these properties that are associated with it. You have 4 tabs. You've got general, security, details, and previous versions. You've got a file name. You got the type of file, which is where we indicate the extension there. You can see where it's stored on your hard drive, how big it is, when it was created, modified, and accessed. This is all metadata that is describing the data that's in that file. On a Mac computer, if you right-click and you do Get Info, you'll get similar kinds of information laid out in a slightly different way. Both of these files existing on the hard drive of the computers that I was working with. All right, so for file contents, what's actually inside the file, not the metadata, we can, if we want to represent a sentence, for example, or we want to store a particular image, we can keep that sentence, that text data, we can store it actually in a lot of different patterns of zeros and ones. We can take some phrase like the quick brown fox jumped over the lazy brown dog, and we can write that and we can store it in different kinds of files, maybe a text file or a Word doc file, or maybe some other kind of word processor file. And even though the same characters are being stored, they're stored in different ways. And so the zeros and ones are different patterns that represent the same text. And being able to understand those patterns means that we're able to understand the encodings of the file. We're able to read the zeros and ones and apply a particular encoding to it, or decoding to it, so that we can read what's meant to be stored in there. If you have a simple encoding, they can often be read by many different kinds of programs. But some programs use very complex encodings that can only be read by a few. So if you think about like a Photoshop file, for example, there are very, very few programs that can open the image that's in a Photoshop file besides Photoshop itself. Likewise, in a Word document, if you store it in a doc file, there are very few programs that can actually open a Word document and read it. But if you store a file in plain text, you can open it with many different kinds of files, TextEdit or WordPad, Microsoft Word, sometimes even something like Photoshop can open a text file. So files that only have text characters in them, don't have images, don't have hyperlinks, don't have sounds, nothing like that, they can use a simple kind of encoding called a character encoding. Character encodings are designed just to represent text. Some programs can read a file even though it's got a special encoding if you tell them how it's encoded. So Microsoft Word is an example of this. If you tell Microsoft Word how a file is encoded, if it can't figure it out automatically, it can read in a lot of different formats. Likewise, some programs can save files in different encodings if you specify it while you're doing that. So often if you save as, you can save images in different formats. If you save as in a spreadsheet, you can save a spreadsheet in a different format, for example, a CSV format. You can do save as and save a text file in different formats as well. All of these are different encodings. Some are interchangeable. So let's look at a deep dive on an example of one. This is a Mac file. The file is called a.txt, and what you can see from this description is that the size is 2 bytes. It's a very, very small file. Its name is simple, a.txt. It suggests that there's text inside, but we don't know for sure unless we know what encoding it was saved with. And we can also see the metadata up above it. So if we right-click and we try and open this file, the operating system is going to give us a bunch of suggestions about what program we should use to open this file with. And the guesses that the operating system are giving us are based on that file extension. You can see a bunch of reasonable examples of programs that might be able to open a text file, and depending on what that application does, what it will do with the text file will vary. I'm going to open it up with TextEdit in this case. And when I open it up, you can see it's a very simple file. It's a text file that just has a capital letter A in it. Now, when I look at this file in TextEdit, what TextEdit is doing is it's taking the zeros and ones that are in the file itself, and it's presenting it to me in a way that's human understandable. It's taking the zeros and ones and it's showing me a capital letter A because the encoding says that that's what's in it as a capital letter A. We can look in specific detail of the file if we use some tools that are available to us on the command line, at least on a Mac and on a Linux platform. So this is a particular tool called XXD. You don't have to be an expert in it. I'm just telling you a little bit about it for background. And I give it a flag -B, and that says output the file that I'm about to tell you in binary format. And then I give it the file name, a.txt. And you can see that the output is one line. It starts with a bunch of zeros telling me that this is position 0 and a colon. And then it has 2 bytes of data, the contents of my text file. And over on the right, it has its best interpretation of what those bytes stand for, an A, and then it shows me a period. Well, I can manually interpret those bits if I want. Rather than using a program to do it, I can look at them and I can identify what's happening there. Let's do that to try and understand what's happening. If we look at that binary number, and if you either know how to transform it into decimal or you type it into a binary to decimal calculator converter, like most calculators can do this actually if you look for it, what you'll see is that binary number is the same as the number 65 using decimal notation. And if you look that up in a character encoding called ASCII, and you look for the column under DEC for decimal, and you look for the 65, you can see that over on the right is the capital letter A. And so what we're looking at here is we're looking at the capital letter A encoded in zeros and ones using the ASCII encoding. Oh, that's interesting. So that's where our capital A is being stored. If we look at the second character, or the second byte there, the second byte there, that's the number 10 in decimal. And if we look at the character encoding on row 10 or decimal 10, we can see that that stands for a new line character. So what we have in this file are 2 bytes. The first byte, if we interpret it using the ASCII encoding, is a capital A. And the second byte, using the ASCII encoding to interpret it, is a new line character, meaning that it goes to the next line when we display it in a text editor. Very simple, 2 bytes, very small file. Let's look at taking a different file encoding and encode the same data in a different file encoding. So here's a Microsoft Word document. I'm going to type in a single capital A, and I'm going to save it to a different file and take a look at it. Save it in the docx format, a different encoding. And you can see that that file is 12 kilobytes long. That's actually 600 times larger than my plain text format. And why is that? Well, Microsoft Word format documents have a lot of opportunities to have things like fonts and colors, images and sounds, database lookups, even a little bit of code in there as well. And so the size of that file, in order to support the kinds of things that it supports, is much, much larger. And if we dig in and we do the same work that we did before, and we try and translate we look at the zeros and ones that are present, there are pages. This isn't all of it. It goes on for pages and pages and pages for 12 kilobytes of zeros and ones. That, if you interpret as a Microsoft Word document, if you use a Microsoft Word encoding in order to understand it, well, you'll get back the Microsoft Word program. Not many programs can understand the Word encoding, though, and so you'll need to open it in a program that does understand the Microsoft Word encoding. Okay, so file contents now. The difference between these 2 files that we just looked at was the encoding that was being used. The first was encoded in a format called ASCII, which is an acronym. The second was a format that was encoded as a docx file or a Word format. There are lots of different formats that can store just characters. The doc file can store more than characters. But if it is a format that encodes just characters, we call it a character encoding, and we use those for text files. Some examples are ASCII. A downside of it is it doesn't support international characters, only sort of English characters. An alternative, one that was developed after ASCII, is Windows 252. This was a Windows-specific encoding that enabled us to introduce some additional characters that included Western languages. So specifically not the kinds of glyphs that you see in Asian languages. Latin 1, also called ISO 8859-1, is an encoding that includes Western European characters. Today we use an encoding called UTF-8. This is the most widely used and state-of-the-art encoding for binary files. And the reason why it's been so widely adopted is because it's a relatively small encoding. Unlike the doc format, it doesn't blow up your files into really large sizes, even though there's very little data in it. But it also supports a wide range of, in fact, all of the international characters that are in use, including some that are from ancient languages and also emoji characters as well. So UTF-8 is the encoding that is used broadly and as a standard right now. Fortunately, it's backward compatible with ASCII. So if you had a file in ASCII and you use a UTF-8 decoder to read an ASCII file, it'll work just fine. If you're in Word and you want to save in a particular encoding, you can do that. You just have to select Save As and then select a plain text file, and you'll get this document. And maybe you've never noticed this before, but there is a bunch of abilities to save in other encodings. And I've done that by selecting the radio button there and then highlighted UTF-8. Now this is the default, so if I had saved this file using the macOS default, it would have been UTF-8 anyway. But you can see that there are a lot of other kinds of encodings that I could potentially use if I needed it for some sort of communication with another computer or backward compatibility or some other sort of reason that might be necessary. There are a lot there that are available. Files, so if that's about what's in the file and how it's stored, zeros and ones that are interpreted with a particular encoding or saved with a particular encoding, we also need to know where the files are stored. And computers store their files in secondary storage. And so by that I mean either a hard drive or a solid state drive. And either that's going to be on your computer or it's going to be on a computer that's acting as a server for you. But each computer that has one of these secondary storage devices on it has a canonical hierarchy where it keeps all of its files. Basically the file system, a system of folders and subfolders where all your files are stored, and they're just stored in one place, if they're on your hard drive, yeah. Operating systems, though, try and help you find your files in a way that's easier, but actually make it kind of hard to know where your file actually is. And knowing where your file actually is really important for being a successful software developer, in addition to just maintaining sanity as you're trying to use your computer and you're writing files of any kind. It's nice to know where they're actually being stored. So let's do a little bit of a deep dive on the Mac OS file finder so that we can understand a little bit how to navigate that. When you look at files in a Mac, you look at a Finder window. And in order to code, you're going to need to know where your files are. So this is an important thing to pay attention to. This is an example of a Finder window on my computer. What I've done is over on the left, I've selected Codex Tohu Bohu, which is the name of my computer. And that has opened this pane on the right where I've highlighted the MOOC video folder. In order to get to the top of your file hierarchy, you select the name of your computer. That's the logical top of your file hierarchy in a Macintosh computer. Then the next place that you want to go is you probably want to go to the place called Macintosh hard drive. In this particular view, what we're looking at is a lot of different external hard drives that have been connected to my computer. So at this point, I actually had 4 external hard drives, one called My Passport for Mac, one called MOOC Video, one called Documents, and one called Big Lacy. Those were all external hard drives of different kinds of technologies. But it's not the internal hard drive that is where all my files are stored on my, that's the canonical place where all my files are stored on my hard drive. To find that place, you click on Mac hard drive. There's often a shortcut to get there, so you don't have to start at the top and go all the way down. And on my computer, I have that set up under a location so that I can jump directly there if I want to. So once I open my Mac hard drive, I see a bunch of different file folders here and subfolders. In particular, I want to draw your attention to the users folder. This is the place where your home directory is. And on a Macintosh computer, your home directory has the same name as your username. So for me, that's DJP3. And if we were to write it as a file path, we would say it is in /users/DJP3. That first slash represents the Macintosh hard drive, the top of your file hierarchy. Users represents the name of this first folder that you pass through in order to get to this subfolder, DJP3. You can keep adding slashes and folder names all the way down until you get to the file that you care about, much like you can in some kind of an IRI or URL. Now you can see that one of the things that the Finder has done in order to try to make this easier for me to understand is that it's put a little home icon next to my DJP3. That's to try and identify it as being my home, but in fact it's no different than any of the other blue folders that are present. It's just a special indicator to say it's a special folder, not like the other ones. And just like my Macintosh hard drive had a shortcut, I also have a shortcut that enables me to get directly there if I click on DJP3 instead. All right, let's drill down a little bit further. If I open up DJP3, I now have a whole selection of additional folders underneath there. You as a user are welcome to make new folders anywhere under your home directory you'd like. Sometimes programs that you use will make them for you. So a few of those have been made by programs I didn't make manually. Most users, however, like to organize their work under documents. So if you were working on a class, for example, you might make a subfolder under documents called Computer Science 101. And then you would put all your work inside that subfolder. There's also a shortcut to this particular documents folder over on the left on my computer, located in the top there. So this is the canonical place where all of your files are stored. There are other kinds of views. You can search, you can look at things over on the left that are going to show your file hierarchy in different ways. But this particular path is the way to find where all of your files are stored, although they may be stored very deep and in very elaborate subfolders somewhere in your computer. One thing you should be very careful of and you shouldn't do when you're writing software, you shouldn't store your code in the iCloud drive. Now the iCloud drive is a very different kind of file system. This is a cloud-based disk drive, similar to Dropbox. And what it does is it caches your files locally and then stores them in an Apple data center so that you can access them on all of your different devices. It's a completely different file hierarchy than the one that I just described. If you store something in the iCloud drive, it won't be stored on your Macintosh hard drive. And if you store something on your Macintosh hard drive, it won't be stored on your iCloud drive. Now, the reason why the iCloud drive is there is so that it's easy to share documents between your different devices. If you put something in iCloud drive, you'll be able to find it on your phone if you're connected to the same Apple ID account. But when you're working with it in a software development environment, the process of caching the file and uploading it to the cloud and then downloading it when you need to messes up the software development process. So be careful you know where you're saving your files when you do that work. Windows has a very similar kind of approach. Windows uses the File Explorer window, but also in Windows you need to know where your files are being stored in order to effectively develop software code. Here's an example of what the File Explorer looks like on Windows 10. And also, it's just kind of confusing to know where all your files are because of all the different ways in which the operating system is trying to show you stuff. It's trying to show you recent files and frequent files, folders, and shortcuts over on the left, but it's not showing you just the canonical location where all of your files are stored. And you need to make sure you know where that is. So for starters, typically the top of your Windows file system is located in what we call the C drive. You may actually have more than one drive on your computer, in which case they'll have subsequent letters like C and D, but usually C is the main drive that forms the top of your hierarchy. If you click on C, if you click on the C drive, so first of all, you may have external disks or multiple installed hard disks that are going to show up as different letters at the top of the file hierarchy. A Mac doesn't show you them as different letters. It gives them different names. All right, so if you click on the C drive, you're now going to start to drill down into the file hierarchy, the canonical file hierarchy on your machine. You can see at the top in that info bar, you see this PC and local disk CD. That's going to show you all the files that you're going down in order to get to your particular files. In this case, we see that there's a users folder. Oops, let me go back one. We see that there's a users folder. And this is where your home directory is on a Windows computer. It's underneath users, and in my case, it's located here in the file Don. The home directory has the same name as your username, and it's located at a similar path name, but slightly different. Windows, as the top of the file path, uses the letter associated with the drive, C:. It then uses the backslash instead of the /, but then proceeds to write the different folders similarly. Users, and then Don, and then however far down I want to go. You can see that that's also reflected at the top of the selection where it says this PC, local disk, users, and then it shows you what's in that folder below it, default, Don, and public. If I click on Don, then it opens up all the subfolders that are underneath the Don directory. And you can see, just like the Mac changed the icon for the DJP3 directory to be a little picture of a house, Windows does the same thing by changing all of these different directories into having little different kinds of icons all the way down. This is I find this very confusing. I wish they would just all look like folder icons. But one thing that I want to draw your attention to is that just like on a Mac, you can make new folders anywhere under your home directory that you'd like in order to keep things organized. For example, making a directory for CS101 and then storing all of your work in there. And if you remember where it is, you're going to be more successful at writing your programs and finding them again later. Sometimes programs will make these folders for you. You can see that, like, probably the music folder was made by a program, or 3D objects. Most users like to organize all of their work under the documents folder that you can see there. Just like Mac, on the left, Windows has shortcuts to a lot of these places that you can get to through their quick access menu. Just like in the Mac, there is a cloud-based storage system on Windows called OneDrive. OneDrive does the same kind of thing that iCloud Drive does, which is that when you store files in OneDrive, they are uploaded to a cloud data center and a copy of them are stored there so that you can get access to them on all your other Microsoft platforms. Again, you don't want to store your code programming work in this OneDrive because that caching process is going to mess up your development along the way. It's not hard to avoid, but if you're not aware of this canonical file hierarchy, you can mess it up pretty easily. Okay, so key points from this lecture. An important part of working with computer text is understanding where and how that text file is being stored. The text is either going to be stored in files. It's either going to be stored directly on your hard drive or secondary storage, or it'll be stored through databases somewhere. Text is made of bits, ones and zeros, that are interpreted or translated into characters by a program that uses a particular character encoding in order to translate those ones and zeros into letters. Thank you for your attention. I hope this gives us a little bit of a foundation so that we don't get lost when we're trying to find our files in the future. Thanks for your attention.